I watched a profile do everything right on paper and still get flagged inside a day. The proxy was set to a residential IP in Jakarta. The browser's own IP checker confirmed Jakarta. The exit node matched the time zone, matched everything the platform could see on the page. And the account still got caught. The proxy wasn't the problem. The DNS request leaving that machine was still resolving through a server sitting in a completely different country, quietly, in the background, for the whole session. The browser's IP and the browser's DNS path are not the same thing. And until you've been burned by that gap once, it's easy to assume they are. I run proxy and cloud phone farms for real multi-accounting work, and I test these anti-detect browsers on my own setups before I write anything about them. I'm not repeating a vendor claim here. I'm the guy who has to explain to a client why a profile got burned when the proxy log said it was clean the entire time. That conversation is what got me actually digging into where these leaks come from, instead of just trusting the IP check in the corner of the screen, and it's a conversation I've now had often enough that I stopped treating it as a one-off. That gap between a proxy that checks out fine on a quick IP lookup and a profile that still gets flagged has a name. It's a DNS leak, and it's one of the most common reasons a setup that looks perfect on the surface produces a mismatched session underneath. It doesn't show up in the browser's own address bar. You have to go looking for it on purpose. If you're running more than a couple of profiles across multilogin, GoLogin, Camelio, AdsPower, or Dolphin NT, understanding why this happens matters more than which of those logos is on the window. The fingerprint spoofing these tools do is real and it's useful, but it's only half the job, and the half that gets skipped is usually the half that gets you caught. Here's the mechanism. Every time a browser loads a page, it has to turn a domain name into an IP address first, and that lookup is the DNS request. Without a proxy, your operating system sends that request to whatever resolver your network is configured to use, usually your ISP's own resolver, or a public one like Cloudflare or Google. That request happens before a single byte of the actual page loads. When you add a proxy, the assumption is that everything routes through the proxy's network path together, the page traffic and the DNS lookups as one bundle. A leak is what happens when that bundle splits, when the page traffic goes through the proxy but the DNS lookups quietly keep going out the old door, over your real connection to your real resolver. The resolver making those lookups is still tied to your real network, your real ISP, sometimes your real country. Anyone watching resolver traffic, or any detection system capable of correlating the browser's claimed IP against the resolver sitting behind it, sees two different networks describing the same session. That mismatch is the tell, and it's a clean mechanical one, not a guess. This isn't some rare misconfiguration you'd only hit on old hardware or a cheap proxy plan. It's default behavior baked into a lot of networking stacks, which is exactly why it keeps showing up in anti-detect setups over and over, even on setups where everything else about the profile looks careful and clean. An anti-detect browser is built to manage the fingerprint surfaces a site's JavaScript can actually read off the page directly: canvas output, WebView parameters, installed fonts, time zone, screen size, navigator properties. That whole layer. It's a real job, and the tools in this category generally do it well. But DNS resolution mostly happens below that layer entirely, down in the operating system's network stack or in the browser engine's own networking code, not in the JavaScript visible surface the anti-detect tool is busy rewriting. Setting a proxy inside a profile tells the browser which server to route page requests through. It does not automatically guarantee that every DNS lookup, every WebTech negotiation, and every background connection the browser makes also writes that same path. Depending on how the engine and the operating system are configured, some of that traffic can bypass the tunnel completely without throwing any error you'd notice. So the anti-detect layer can be doing its job perfectly. Canvas is spoofed, fonts are spoofed, the time zone matches, while the network layer underneath is leaking the real origin the entire time. Two different systems doing two different jobs, and in most setups I've seen, only one of them ever actually gets checked before the profile goes live, usually because the fingerprint side is the part that's easy to see and the network side isn't. A few concrete mechanisms account for most of the leaks I've personally traced back to their source. On Windows especially, some proxy configurations only route TCP and UDP traffic to the destination through the proxy. While DNS resolution for that same destination happens locally first, using the system's configured resolver before the connection is even opened. If the profile's proxy type doesn't carry DNS with it by design, this is the default failure, not some rare exception. And it happens whether you're running one profile or 50 of them side by side on the same box. Weirdity is its own separate problem, and a nastier one. It negotiates peer connections using stun, and stun requests can reveal a local or public IP completely independent of whatever network path the browser claims to be using. Because Weirdbetsy was built to punch through net, not to respect a browser-level proxy setting. A profile can pass every IP check on the page and still leak a real IP through a stun request firing quietly in the background the whole time. IPv6 causes its own version of the same problem. If the machine has IPv6 connectivity and the proxy only handles IPv4 traffic, the browser can fall back to a direct IPv6 route for some requests, and that route never touches the proxy at all. It just goes straight out. Most people checking their setup never think to look for this one because the IPv4 check up top looked fine. Browsers also try to speed up page loads by resolving domains and pre-connecting before you've even clicked a link. And depending on the engine version and its own network settings, that prefetching has been known to bypass a proxy tunnel that regular navigation otherwise respects properly. It's a small thing, it happens quietly in the background, and it's exactly the kind of small thing that adds up across 100 profiles running at once. None of these four mechanisms are exotic or obscure. They're standard behavior from general-purpose networking stacks that were never designed with per-profile traffic isolation in mind in the first place. Antidetect vendors build on top of Chromium or Firefox, and how thoroughly each one closes these specific paths depends entirely on their own proxy handling code, not on the fingerprint spoofing that ends up in the marketing copy. Checking your own setup for this is simple, and to be clear, this is about verifying what your own tools are actually doing on your own machine, not probing or working around anything that belongs to somebody else. Open the profile with its proxy active like you normally would, then load a DNS leak test page in that same browser window in that same session. Compare the resolver location and the reported IP location it returns against the proxy's actual exit location, which you should already know because you're the one who set it. If the resolver traces back to your home ISP or your real country, while the proxy is supposed to be somewhere else entirely, that's a leak, full stop, no interpretation needed. Run the same kind of check for WebTech specifically, using a page built to reveal any IP address a browser exposes through stun, independent of whatever network path the browser claims. If a local or ISP IP shows up there, while the address bar's own check is showing the proxy IP, you've isolated the leak to WebTech rather than DNS generally, and that changes exactly what you go fix next. And do this per profile, every single time, not once for the whole install and never again. Because different profiles inside the same tool can end up running different proxy types. SOCKS 5 versus HTTP versus some chain setup, and the leak behavior is not consistent across them. A clean result on Profile 1 tells you nothing at all about Profile 12. The fixes themselves are mundane, which is probably exactly why they get skipped so often. Use a proxy protocol that supports remote DNS resolution and configure it that way explicitly rather than assuming it's already on. SOCKS 5 can carry DNS through the tunnel, but only if the client is actually told to resolve remotely instead of locally. That's a setting you have to go set. Never a given. Disable the retopsize the profile if the tool gives you that control, or restrict it to the proxy interface specifically. Most tools in this category expose some form of retopside handling in their profile settings, but whether it's a hard disable or a proper proxy bound mode depends on the specific tool and the specific version you're running. So go check the current setting in your own install rather than trusting what an older version used to do. Turn off IPv6 at the operating system level on the machine running the profiles, if the proxy you're paying for only handles IPv4 traffic. A dual-stack machine talking to an IPv4 only proxy is a standing leak path sitting there open until IPv6 gets disabled or explicitly routed through the same tunnel. Test after every change you make, not before it, and test again after engine updates land, because they will. A setting that closes the leak cleanly on one browser engine version can quietly stop working after an update ships. This is a recurring category of problem you revisit, not a box you check once and forget about for good. DNS leaks matter because they're one of the more mechanical, checkable ways a profile's claimed location and its real network path can end up disagreeing with each other. But closing a DNS leak doesn't make any browser undetectable, and it doesn't mean an account is safe from review or suspension. Nobody honest can promise you that, and anyone who does is telling you what you want to hear, rather than what their own testing actually shows. Fingerprint consistency, browsing behavior, account history, and a dozen other signals all factor into how platforms evaluate an account. And no single configuration change removes that risk. It just removes one specific avoidable way of standing out for no reason, which is still worth doing. It's just not the whole picture. If you're running proxies and cloud phones for real multi-accounting work, treat the DNS leak check as a routine part of setting up any profile, the same way you'd already check the proxy's own IP before trusting it. It catches a mismatch that's easy to miss and honestly easy to fix once you know exactly where to look for it. I test these browsers on real multi-account setups, so the written reviews and the picks I actually trust are all at antidetectreview.org. Full written reviews and tested picks at antidetectreview.org. And if this kind of hands-on breakdown is useful to you, go subscribe.